Alright, last time we checked out the sub 10 liter SM550. I've since made a few updates to it, but I was curious to see how this one would work. This is the Noctua L9x65, but as you can see, there's no fan on it. So let's take a look and see if this semi-passive build actually works. Welcome to Machines and More. Just a quick update here on the Sliger SM550. It's a fun little case, and I had a chance to tweak it just a little more and try a few things here. I've had this one for a while, since the Zen Plus days. It's seen quite a few iterations. You know, at one point it was a 2600 and a 1660 Super Build. I've tried that CPU with a fanless Be Quiet Shadow Rock LP, and just recently I popped a 3600 into here and I popped a 3060 Ti into this case. But I wanted to see how this one would work, and the idea is that the heatsink is drawing heat from the CPU, but there's no fan used for heat exchange. And normally you'd have a cooler fan, and that's venting off the heat from the heatsink. But instead of this guy, we'll use the two case fans. These are the two Arctic P12 ARGBs, and that'll draw the outside air in. This type of setup does require the use of solid panels on both sides, since, you know, if there's a path of least resistance, that airflow is just going to bypass this heatsink and it's just going to waft out the sides. Typically for a sandwich style case, it'll come with vented panels, and you can option this case with those vented panels, but I opted for these acrylic panels early on since I was very curious to try this more niche type of SFF build. And since this one is strictly a gaming build, this type of setup can actually work acceptably well. So today I just wanted to give you an idea of what those thermals look like if you're interested in trying something like this out. And a big thanks to Noctua for providing the cooler and making this test possible. First off, we're going to keep the CPU undervolted, and this is a must-do even with a fan-equipped cooler in this little clearance. And that's actually quite doable in this case, since this particular 3600 is actually quite decent. It can run at 4.0 gigahertz on all cores, which is typically your max stock all-core boost clock, but it can do that with a scant 1.075 volts. Said another way, there's not much of a performance hit versus stock performance by dropping the voltage when we lock it this way. These fans are pretty quiet, and they only top out at 1800 RPM, so I just set the curve that they would run at 100%, and you know, let's take a look at those thermals. Right off the bat, it was definitely a little toasty. Even in my 20-degree ambient room temp, it was coming in the low 80s, which is not terrible for the GPU in a case like this, but for the CPU, it's definitely running hot. And that's especially if you're considering this is only about 30% utilization here. What's happening here is that this Gigabyte Gaming OC 3060 Ti, it's overclocked pretty hard out of the box, and we are looking at about 236 watts of GPU power, which is a lot to go into a case like this, and that's resulting in a pretty high ambient case temperature, so it's adversely affecting the CPU also. So one thing you should always consider doing in a build like this is to undervolt the GPU. And I dialed in a roughly 60 millivolt undervolt, which brings the total board power down closer to reference specs at about 200 watts. But at the same time, I managed to up the clock speed higher to 1905 megahertz on average. So despite lowering the power, it's actually overclocked even more now. So that helps performance, but it also helps mostly with the thermals in the case. And in a GPU limited scenario, such as my test case for gaming here at 4K, it's actually pretty good. With the lower power, the case air is going to be a lower temperature, so that helps out the CPU cooling. It's still not what I would call great, but at least at this level, you're not likely to run into any problems when gaming long term this way. And again, we already locked the clock speed, so the only thing we're missing out is the higher intermittent single core bursts above 4.0 gigahertz that PBO might boost to. And for AOE 4, I was still around 80 and 90 FPS in 4K with most settings on high. So really, in a title like this, it's not going to matter. Compared to the L9x65 with the cooler fan and with all the panels open, yeah, there's definitely quite a penalty for this setup. But outside of the noise from these fans at a higher RPM, the gaming performance here, it's really quite similar. So strictly speaking, it can work, it's acceptable, and good silicon definitely helps. From my calculations, this type of CPU cooling setup can maintain a safe equilibrium temp with about 35 watts of CPU package power. So for most GPU limited scenarios for gaming, it's going to be okay. And actually, I was a bit surprised that it was still able to work with the higher power GPU in here. And given that the L9x65, it's not really supposed to be for this type of setup. And you do want to run a fan with it typically. Of course, this type of performance means that any type of heavy multi-core usage is out of the question, and this will easily throttle if you try to do any type of CPU rendering. So if that's the purpose you have in mind, I'd say you definitely don't want to set it up this way. Plus, I think you probably have the wrong type of CPU for that. In theory, this type of setup can work much better if there's a purpose-built cooler. The tight fin density here doesn't really help. And if you look at a real passive cooler like the Noctua NHP1, the fins are pretty widely spaced and heavily built up. So what I'd be really interested in seeing is an SFF-specific low-profile passive cooler with wide heat fin spacing and a big footprint, maybe even spanning the entire surface of the motherboard. And I think that would be a very intriguing possibility for this type of build. So alrighty, that'll do it for this update. I'm actually going to be pulling this CPU and I'll try it out at the other end of the spectrum. We'll see just how hard you can push a good 3600 and compare it against a 5600X and how relevant this one still is. So do look for that experiment coming up soon. Give a like, subscribe if you haven't already. Thanks for watching.